Okay.
Ready, set, go.
Okay, go. So today's topic is diverse preference optimization. It's short as the DIVPO. Um, the content is we have four contents. Here is the brief contents. Let's start with the diversity challenges in the LLM. Uh, so as we all know, that large language models are proficient at producing the high quality human aligned outputs in responses to a particular prompt. And how do we get such a model? First, training the pre-trained stage. Large language models are trained to a model that learns distribution matching massive data, just just like llama. And then during the post-training stage, this model is aligned with human preference over the responses. We call this process, usually we use this reinforcement learning from human feedback. It's as RLHF. Uh, However, this alignment unfortunately results in a difficulty in producing a diverse set of outputs. Diverse set outputs is important. First, tasks such as creative writing, idea generation, and biological sequence designs explicitly require and benefit from diverse generations. And second, recent works on interfaces scaling laws show that LLM reasoning improves when searching a more diverse candidate space. And finally, LLMs are often used to generate synthetic training data. So, in brief, we need diverse uh, outputs. And why low diversity is due to the alignment collapse. Here we can see the whole process of a traditional RHF. Uh, and during this post stage, you can see uh, the model is aligned with human. And in this stage, we usually use RHF to train the model to fit human's preference, which contains three phases. The first phase is supervised fine-tuning. Um, we have the pre-training large language model, and then we use some uh, prompts and answer pairs to train the model. So we get a basic policy model. Then we use these policy models. We get some. We give it some prompts, and every prompt we may have several responses. These answers we invite some people to evaluate to get some scores. Then we build the prompt, response, and scores pair. We use these pairs to train a reward model. I mean, feed these pairs to a pre-trained model. We get the reward model. The reward model can give the scores to the answers. Then we use this reward model and the basic um, policy model in the finally stage. We use it uh, in a loop to train it. First, in this phase, first we um, import some prompts to the basic policy model. The basic policy model will give some answers. Then we will give the answers to the reward model. Next, we get the score. We use the score and answer. We use the score to optimize some parameters in the basic policy model. So we do it again and again. And in in these iterations, we will increase the probability of good answer and decrease the probability of bad answer. So finally, we get this policy model, which should have how I can say align with the most aligned with the human's preference. So here and this stage is the collapse happens. So why? Because in the finals, we usually use the loss function. So the objective of reinforced learning causes collapse. We can see this loss function, or also we can see as the reward. And the R sub t in this means which means a reward for generating a token at time step t in case of text generation. So obviously, putting all sequence levels probability mass on the highest reward responses is an optimal solution to this loss. So everything becomes the highest. So let's see some next section. Let's see some start of the R's method and what happened in this method and how they against the collapse. So first, it's KL term. You can see it at the one part here. Regularizing KL terms with respect to a reference model is often added to the RL loss to solve the collapse. So KL term is used to measure the difference between two distributions. The pi and the pi sub reference, it should be two. You can treat it as two distributions. So if KL approached 0, which means these two parts are similar, and if they are different, the KL will be large. And the pi should be the current policy model. The pi sub. Oh,
Fengran, yeah, just to interrupt the question, the figure confuses me. The policy model is the LLM itself, right? It learns policy internally. It's not like not yet another. Like how many neural networks are there? LLM, the reward model, and that's it? Or LLM policy? Like what is pi there? Pi is the distribution produced by pre-trained network before we started here, right?
yeah. How can I say? You can see this
Yes, yes. What is
yeah, this
LLM
picture.
policy?
So LLM policy, you can treat it, cause in this stage, do you remember that we get a basic policy model? Yes.
Oh, but that's the language model basically. It's only you keep training it, and that's the same language. Well, not the same, but it's modified language model, the one that you train. That is your policy network, right?
Yeah.
Okay, okay. So, what in scale divergence? Why don't we just keep it with scale divergence sense similar to the unfine-tuned, the raw model? So the distribution is as data faithful as possible, or is that what we're trying to
Oh,
do?
I knew. You may ask why we need the reward model.
No, no, reward model is fine, but while training in tail divergence term, you can tell, okay, train me a model such that maximizes reward, but the distribution stays the same as a regional data distribution.
PL is a hack.
No, I mean, everything.
Oh,
This one is specifically a hack. It's derived from, it's a derivation branching off from the policy gradient methods. It's simulating a trust region. And so it's called ref as opposed to the original policy because you actually want to move ref as you continue training. And so ref in practice, like say in DeepSeek, is set to be like 10 or 15 iterations behind the current policy to actually maintain three different
instead of just sticking to the original one,
yeah.
Why don't you want to just stick it to data distribution? Why do you move it?
Because that means that there's basically like a string tied to your current policy, and you can't navigate past a certain metric away from your source policy. You do actually want to go away from it. You want to go away from it in such a way that it still maintains a bunch of the same properties as the source weights.
Yeah. Why don't I want the data distribution? Like because
it's not expressive enough. If you tether yourself to the source policy, you can only change the distribution by so much. And given that, like, hyperdimensional ball of
there's everything in this. The dimension. Okay, anyways, we're digressing. Thank you. Yeah.
Does it like slow the drift away from seeing?
No, it's just like if you don't have the KL term, then it will collapse very easily. But if you KL against the base model, then there's basically like a
no, but that's what Pavel said.
There's a strict cutoff.
It's just a kind of an inertia term you have. It's still moving past few steps.
Yeah.
But you're kind of
yeah. It's basically saying for this first step with respect to the reference model, don't move too far from it, and then you iteratively update the reference model as you move along.
Yes.
Yeah. It's a hack though, because a lot of libraries actually remove the KL term. A lot of implementations remove the KL term.
Can't collapse.
It doesn't collapse. No, it's interaction with a bunch of other things that people don't understand. Like LoRa, for example. If you use LoRa or if you use low quant fine tuning, then it acts like a regularizer. You can also do gradient clipping. That also kind of works.
But it not loves it.
Yeah, gradient clipping is awesome.
Okay. Should I continue?
Please.
Okay. Just as you talked that, I think we are clear with the pi and pi subrefer. Yeah. So
Yes.
all this part is, yeah, you say that the current model should not be too far from the reference model. I mean the original model. So we can adjust the beta to balance the high reward and the original distribution. This loss is used in the PPO and DPO, and we will touch DPO next. So DPO is direct preference optimization. Compare with RHF, I mean the traditional PPO. You can say DPO does not need a train explicit reward model. Yeah, it's just skip the reward model. It's directly use the preference pairs to optimize the policy model via a classification style loss, like this formula. So in this formula, the pi sub theta of y given x means the possibility of the model pi sub theta response is y for prompt x, and y sub c means the choosing answer. You can tell it as good answer, and y sub r means rejected answer, which is a bad answer. So in this process, first all the same, but in second, we use this loss function, and also we change the input data. I mean, usually that you can see in the last, we use the preference data to train the reward model, but in the finally, we also use we use their scores to do the reinforced learning fine tuning to do their policy model. But in this method, we directly use their preference data, which means we have their prompts, answer, and also the scores. to train their basic policy model. And in this process, we get the final policy model. So
can you comment how YC and YR come to be? The model generates with higher temperature a few answers, and the user selects one of them.
It's YC and YRU. It is chosen by the humans. I mean, like, we give one prompt to the model, then we get several answers. We will ask the people to mark it as chosen or rejected. It's kind
unscalable. Okay, yeah, this is
Yeah.
unscalable. So, I get it.
Okay. So, but still, there were some limitations in the diversity. I mean, whatever the RHF or the DPO, this substantially decreased the diversity of languages models outposts along several linguistic axes, even with the collaborating with humans. The first is that the high beta is not okay. If we want to increase the diversity of the model, whatever in the RF or the DPO, we need a higher beta. This term you can see. This term controls the, I can say the balance between the current one and the original one. I mean the reference model. So we use this to control, but higher beta will force the model to stay similar with the original one, which is less will align with human preference. And the second, with evaluation metrics. There were several metrics like accuracy, parse at n, and win rate. They all focus on whatever the quality rather than diversity. These metrics can often be optimized even if the model always generates the same response for a given prompt. So what we should do? There is a new method, diverse preference optimization. It's short as the DLAPO. So the DLAPO was pretty similar with DPO, to be honest. They share the same optimizer, which means that they share the same loss function. I mean this one. And difference that is the preference pairs selection in this part. They do something. So let's say, you can say that before, we usually just do the choosing and reject. But in this method, we also add a diversity criterion. And we also set a reward threshold theta. Threshold row. So what did it do? First, we get some choosing set, like before, and according to the rule, the rule is that I can see is the percentage range from the lowest to the highest reward value. For example, like here is all these. Here is all this set. I mean all the answers. We have 5 answers, and if we set the row is I can say it should be 0.4, which means that we should chosen or reject 5 2 out of 5 of the answer. So we have two chosen answers and 2 rejected answers.
So wait a second. This
Mhm.
ranking is according to humans labeling each of those answers, right? How do you get the reward value for each Y? The humans are sorting them, right? And you somehow setting up.
Oh, I know what it means. I mean, we can treat that the reward for the choosing, the reward is 1. If reject, the reward is 0.
Well, but you have sort of a score, right? You sorted them, you rank them by the score. Where is the score coming from?
Yeah, what's the diversity criterion? Is the question.
No, that's another one. I can come up with that. It's an ensemble metric and stuff like
Yeah,
that.
I mean the
But
score
how
you
do you
can.
even rank them first? Because look, they ranked, and you take the first half, and that's your ensemble for choosing the most diverse. So you can compute the mean, and the one with the highest distance from the mean is the most diverse and stuff. But how do you even sort them? By what value? Where is that rank?
Oh, I got your means. Let me see.
Yeah, like the sorting is by something, right? By some, you call it reward score, I guess, right?
Yeah.
Like I imagine we show it to 20 humans. Each one does I like, I don't like, and you kind of can get some numerical value or some ranking.
Maybe we can treat it as how can I say, maybe we assume that when we have the score from like to 1 to 10.
Oh, so but humans will use that score.
Yeah, this score, then we give the score to each answer, and so we can just give the sort of all these answers.
This
And
is like
then
so unmanageable.
Yeah, it's very scalable.
That's scalable. Yeah, how can you like you hire tons of humans to do this for you? Okay, or at least in the case of what's the coding? The codex or not codex? What do they call? They do it online. Like people.
Oh yes,
in
cursor.
Cursor does it, right? There, at least you get raw human preferences.
Looking at the paper now, and I don't see anything about sorting based on the reward.
Well, but that's what the figure selection method, right? Well, based on.
I thought the sorting was based on the diversity criterion. That was my.
Well, the diversity is after, right? The most diverse.
Well, I think this is just artificial for the figure, right? They group them together to show the most diverse at the top and the least diverse at the bottom.
Well, but then the diversity is an ensemble metric. It's a relative metric. One single sample cannot be diverse if there is no other things to check it.
Takes it. Yeah, I mean, they talk about the diversity.
oh wait, I think the reward value. Sorry, I think it should be get from this.
So preference. So user well, choose an answer, rejected answer.
Yeah, it's not user input at all. But
Oh, okay. So you're taking so you're saying the reward is you push your Y1 through your old model that is lagging behind in the new model, and that's your log ratio of those softmax scores, basically, the conditional probabilities. Okay, that's possible. And then you sort and you sort by that and etc. Okay.
Yeah, and then after they get they just have the chosen setter and the rejected setter. It will impose these items to a diversity criterion. It will choose from this side to get the most diverse one.
So the most remote from the mean, I guess that's how you like. I don't know how they define diversity, but
Yeah. So you can see in this also for the rejected one, it will for the rejected side, it will according to the diverse criterion to get the least diverse one. So we get the DYO pair. It's the pair is different from before because before we just evaluate this only according to the reward, but now we added the diverse. Yeah.
Mhm.
And and if the though is 0, both this side will be because 0 means that the percentage is 0, so which means that we only choose 1. So all of this set will only have 1 item each. So it will making the DIPO equivalent to the DPO. Yeah. Because if we only have 1 in this part, we only choose this 1. So everything becomes same.
Good, thank you. Yeah, go
Okay.
on.
So I think the critical part should be the diversity criterion. This part, we usually now have 3 methods. First is model probability. If a response y sub I has a higher probability under the model, that means that it's more likely to be generated again, hence less diversity. Yeah. And second was word frequency. The response with the more frequency word is likely to be similar to other responses sharing the same words. Yeah, so we can see that if this happens, that always less diversity. Second is LLM as a diversity judge. We prompt a large language model to select the most and the least diverse responses from the chosen and reject side. Yeah, here are 3 methods we can use. And training this, the DIVPO supports 2 kinds of training. First is offline policy. We generate all the pairs at first, then training. And second was online policy, and we generate the pairs for the current batches of prompts and at every steps. So online training, other optimization approach has shown preference improvement at the cost of computational efficiency. And in standard methods, however, online training is known to be a more prompt to collapse. The LVPO is effective on both methods. So let's see the experiments and results of the method. So first, the situation was personal generation task, which means that we generating a random character person description by prompting the model to produce a JSON object containing various attributions like first name, city of birth, and occupation. So we use their probability and word frequency as a diversity criterion. So you can see the result here. And you can see it's obvious like whatever the diversity is obvious like the DLAPO have a great result. And for the quality, it may have some, I mean, just a minor decrease compared with the traditional methods, but not too far away from. So I think that it can achieve a higher diversity with a minor loss of the quality. So it's acceptable.
Can I ask a question here? So you have two things, this GPO, frequency measured diversity and probability measured diversity in the method column. But then you have the column diversity higher, better. Which diversity is that? Frequency or probability? The one with the arrow. It's like,
Oh, yeah. You can see here is use different criteria. Oh, you
yes,
want to know which one is better?
which one
Uh,
is here under your mouse? So yeah, like which one
I
are they sorting by?
I think that for these two is you can see is according to I mean is related to their attribute.
Well,
Yeah,
but
someone
diversity,
is better and someone maybe this one is better.
how do we
So
measure that diversity? I mean, do we measure by frequency or
uh the like let me back.
okay, okay.
Yeah, you can say the first one is a probability, is response.
No,
Uh,
no, I understand that. Go back to the table. So I thought maybe from the paper. So diversity with the arrow.
They've got three different criteria.
No, no, like, but only one is shown here.
Oh, yeah.
Which one? Uh, which one is shown in this table? So they selected a criterion for according to which their models are best.
Number of
Which,
unique attributes
oh,
divided by the total number of generations satisfying the rule-based reward.
so it's not the one that they trained with. It's not the frequency. It's not the probability.
No, this is
Thing.
like a performance metric.
And they called it a different one. And they
Yeah.
called it diversity.
Yeah.
Okay.
Very confusing.
But they could have trained. They could have trained on that as well. Like for example.
Yeah, it might not be as different. It's differentiable. Why not? Yeah, yeah.
Okay, good. Thanks. We got it. Yeah, Fengran.
okay. The second scenario is the keyword story generation task. We prompt a language model to write 5 keywords that could be used in a story with a particular title. You can see it was a simple task, and we use 3 criteria. And here you can see that the y-axis is diversity and the x-axis was quality. You can see that here is a llama. It's a pre-trained model, and here is the method we use DPO, and here is the DIVPO. So is this one should be more obvious than the task before that. We can see that the DPO can achieve high quality with also high diversity. Any question here? So the next, yeah, I just choose this to oh wait. Oh, I have seem like I had some. Oh, I have skipped something. Oh, also for the first task, I'll just skip one slide. There was the top frequency name attributes that you can see that for the other ones, maybe they are not even. But for the DIVPO, you can see the blue one. It shows like more even than other 2 methods. Yeah, that's it. Okay, thank you.
Yeah, thank
Oh,
you.
okay, there was also 2 paper. I think one is about DPO, one is about the tradition. Should be a review. Just I send it to the
Yes,
chat.
if you can. Yes. I'll transfer them. Any questions to Fengran? Any additional questions? I have a question then. How are you using this in your research?
We have a project that we want to we give some prompts. How I can say we have picture. The picture is a scenario, and we want to use the usually this picture is used to evaluate if the people have some mental health issue or whatever. Usually the doctor will request the patient to describe what happened in the picture. Then he will just try to evaluate the answer, so he can know if there are any issue with the patient. And we want to train a model to, how can I say, to replace the or assistant with the doctor to evaluate the patient. So obviously, we need enough description or the answers from the patient about this picture. So we want to use the LM to generate their answers as a training data. But you know that usually if we want to have some high quality training data, we need to we need the diversity should be enough. So that's when we use DIVPO preference optimization. We want to use this method to increase the diversity of the LM, so it can generate the diversity answers to the diversity description to the picture, so we can do the next step. Yeah, I think that be the why we want to the DIVPO.
Yeah, that's interesting.
Yeah, I'm a little bit curious about this idea of using diversity of outputs as a desirable quality, right? So certainly in some contexts it would be desirable, and I get the idea of controlling for this collapse in distribution. That makes a lot of sense, but this kind of post hoc diversity approach is a bit strange to me. I mean, they also show in that figure that it has a trade-off with the quality of the responses, right? So, and like, is it really something that's desirable? Would I want someone to say 5 different things to me if they're all low quality, or would I want to hear the same thing 5 times that's high quality?
I'm mapping this to humans too, and I found 2 failure modes. One failure mode is an agitated, highly verbal child who speaks a lot, fantastic stuff, and nothing is connected and it's not going anywhere. But another failure mode is reverse, is like when you're too focused, like almost schizophrenia, catatonic, on one idea, and the person, we see them on the streets, unfortunately, here on our campus, keeps repeating the same phrase over and over again, no diversity at all. Right? Like, how can we just, we don't want neither one, nor collapse. Like we want some goal-directed text production. I don't know.
Right. And if like there are goals along this line to address problems like the model sycophancy and stuff like that, like which this kind of work might be used to address, yeah, again, I don't know, because you need a model that will sort of stand its ground in the right way and not just sort of, you can still have sycophancy with diversity. I don't know. There's like it's an interesting approach. I don't quite know the utility of it directly.
Yeah, what do they do in industry, Mike? Do you know?
Why is diversity of responses desirable in particular? versus quality.
Besides just distribution.
Are we still being recorded?
Let's stop the recording.
We're gonna stop that. Sorry, online people. There were some confessions due. And, thanks for watching that. And yeah, we'll see you next week.